Good afternoon, YouTube. Welcome back to the channel. Welcome back to another lunchtime study hour. Today we're going to be working through another lab, this time another guided lab, similar to the ones we had done earlier on in the channel with Jeremy's IT Labs. But this time, now that I've got CML up and running, I'm going to be trying to focus on working with that. And I was looking on the internet for labs that were CML specific and came across this wonderful GitHub repository, Cisco DevNet CML community. And if you see this name here, Hank Preston, and you've done any of the CCNA-Prep stuff with Cisco, you know that he and Patrick Gargano host a series where they're essentially walking through various topics related to the CCNA. So I thought that was perfect. If you jump into lab topologies here, you can see CCNA-Prep, and there's a bunch of others, obviously. And I just started at season 1, episode 1, this one, Mastering Vlan Configuration. And so what you get is a guide, which we will go through, which is excellent. You get the YAML file that you can import directly into CML, and it brings up the whole lab. So I thought that was pretty cool. And today we're going to walk through the season 1, episode 1 scenario. All right, so I'm just going to flip back and forth between the PDF here and the lab, and we'll see how it goes. All right, CCNA-Prep, back to networking basics with Hank Preston and Patrick Gargano, mastering VLAN configuration. All right, so we're going to do a bunch of stuff with VLANs that we'll get into. I really like the scenario. The setup and scenario is very much like a real-life scenario. In this set of lab-based demonstrations, you are a network engineer for a growing organization tasked with updating the network to support new network needs. The network traditionally has had 2 small network segments, one for employees, one for guests. You're getting 2 requests to add network connectivity for the IoT devices in the organization. They need to be segmented away from employee and guest traffic. All right. The organization is growing and it needs to add new network capacity to support additional users. These new users will be located in new office space being prepared in a different part of the building. The following lab-based demonstrations will look at how VLANs provide solutions to these requests. In a real network, there would be additional security, for example, access control lists or firewalls. That's out of the scope of this thing. All right, so demo number 1. Before we dive into creating and managing VLANs, let's remind ourselves of what life would be like without them. Our starting network, so let me zoom in and bring that up. Maybe I can... Our starting network, little sensitive, okay. Our starting network is composed of 2 simple unmanaged switches, the employee switch for employees and the guest switch for guests. There is also an iOS router called Router that provides routing between the network segments. Goal: to support the new IoT devices, we will be adding a new IoT switch to the network. Router interface Ethernet 03 is already configured for the new IoT devices network segment. IoT host is already configured with an IP address for on the IoT devices network segment. Okay. So testing the current state, open the console for the employee host, and ping the guest host, and then confirm that that is successful, and then ping the IoT host and confirm that it is not. Okay, so let's go ahead and click on this guy. Wait, no, the employee host, not the employee switch. All right, and we'll jump into the console. Let's see, Cisco, all right, and we got a freshly spun up Alpine Linux system here, and we're going to ping 192.168.2.11 because that is guest host. Those are the instructions, and confirm that that's successful, which it is. All right, so 4 packets, 25% packet loss. I think that's expected. I think that's still considered a success. All right, and now, what was the other one? Attempt to ping IoT host with command 192.168.3.11. All right, so let's do that. 3.11. And obviously there's no connectivity, so we would expect this not to work, which it won't. All right, so 0, 100% packet loss. Okay. So let's move forward. Adding a switch network for IoT devices. Okay. Add a new unmanaged switch to the IoT device's network block within demo 1. Name this switch IoT switch. As this is an unmanaged switch, there isn't any configuration needed. Start it and then add the 2 links. All right, so let's get back to that. So we're going to add a node here, and we need to get an unmanaged switch right here. Drop it here. All right, and we will name it something different. I think it was IoT-SW. Let me just confirm that. IoT-SW, yes. It's an unmanaged switch. Start the unmanaged switch. So start. All right, and now add 2 links from the router interface Ethernet 03 to port 0. Okay. So the router's Ethernet 03 to port 0. That link is created. And then from the IoT host interface Ethernet 0 to port 1. All right, so we're going to create a link. IoT host Ethernet 0 to port 1. All right, that's already configured. Okay, return to the console for the employee host. Retry pinging the IoT host with command 192.168.3.11. All right, we would expect it now to work. Let's see what happens. Nothing's happening. Seems like it's not working. However, I've run into this in the past. Let's see. Let's look at this. Okay, so we need to make sure that the connection is running. What about on this one? Those are both up, and they've sent and received packets. Okay, so let's try that again. And it's working. Okay, so that's a little tricky. Don't forget to, it's a CML thing, but within the configuration settings for the link, make sure that things are running. I've been troubleshooting at times, and that was the issue. All right, so we did that. We ensured that it was successful to 3.11. Conclusion, we've been able to support the new network segment by adding an additional switch. However, consider what happens as the number of network segments increase from 3 to 10 or 20 or 100. The number of physical switches required will quickly become challenging. Also worth considering is the router requirement to support this number of switches. Okay? All right, demo number 2. My heater just kicked on and it is loud. Demo number 2. In this demonstration, we are looking at how we can replace multiple unmanaged switches with a single managed switch and maintain the segmentation of VLANs, or with VLANs. The starting network already has an iOS-based switch named Switch with links to each of the hosts in the network. There are the following hosts: the employee host 01, the guest host 01, IoT hosts 1 and 2. All right, so let's take a look, first of all. Where are we at? We're at the demo number 2. All right, now, well, that's kind of nice. They can just actually both be in the photo at the same time, in the video at the same time. All right, so we've got employee host 1, guest host, and IoT hosts. Okay, in this demonstration, we are looking at how VLANs enforce layer 2 network segmentation. To explore that, each of the hosts have been assigned an IP address in the same 10.000 network. We will use these addresses to test and verify the segmentation. All right, goal: to create 3 VLANs and configure each host in the proper network segment. Great. As we start, the only VLAN that exists on the switch is VLAN 1, the default VLAN. All hosts are on this VLAN and therefore should be able to communicate with each other. So we're going to confirm that, testing the starting state. Open the console for switch and look at the starting VLAN configuration with the command show VLAN brief. All right. Open the console for switch. And I think we can get rid of this old employee host from the first demo. All right, so en show VLAN brief. We've got one default VLAN, okay? VLAN brief. In addition to VLAN 1, you will see VLANs 1002 to 1005. These are special purpose VLAN numbers used for older non-Ethernet based networks and are out of scope for this lab and the CCNA. On iOS switches, the configuration of normal range VLANs 1 to 1001 is not stored in the configuration file, but in a special vlan.dat file. Because we don't have any VLANs created yet, this file does not exist. You can verify the command with the command dir. You should not see the vlan.dat file. All right, let's try that. I do not see a vlan.dat file. Open the console for IoT host 01. Attempt to ping the other host. Ping blah, blah, blah. All of these should work. This is because each host is on the same VLAN. Other ways to say this include all hosts are on the same network segment. All hosts are on the same broadcast domain. All right, so let's go to IoT host 1. And we'll go ahead and, my chair is syncing. IoT host 1. Cisco. All right, and 10.0.01, 02, and 03. Oh no, 04, all the other hosts. Ping 10.0.0.1. That is successful. Ping 10.0.0.2. All right, 95% CPU usage. Okay, that's successful. And 04, the only other one. And that is successful. All right, what's next? All of these should work. This is because we're on the same VLAN. Okay, so creating VLANs. Now we will create 3 VLANs. Okay, so we're in the switch. Go and create the 3 VLANs, 10, 20, and 30. Employees, guests, and IoT devices. Let's do that. So we're in the switch. En conf t VLAN 10 name EMPLOYEES, so employees, capital, okay. Exit VLAN 20, so we've got 2 now. Employees, this is guests. Exit, and VLAN 30 IoT dash DEVICES. IoT devices, exit. All right, we got the 3 VLANs. Repeat for the other 2 VLANs, changing the numbers and the names. Okay, verify that the VLANs were created with the show VLAN brief. Do show VLAN brief. And we've got them created and active, 10, 20, and 30. All right. Verify that the vlan.dat file was created using the dir command. Let's do that. Do dir. There we go. And we have the vlan.dat file. All right, that's expected. Moving hosts into the correct VLANs. Okay, so it would appear what we're going to need to do is put each of the interfaces of the switch into the correct VLAN for the VLAN that they belong to. We have created the VLANs, but all of our hosts are still in VLAN 1. To move the hosts into the correct VLANs, we need to change the access VLAN for the related interfaces on switch for each host. Okay, so we got to open the console for the switch. We did that. Look at the current switch port configuration for interface Ethernet 01, the interface connected to employee host 01. Use the command show interface Ethernet 01 switch port. All right, so show interface Ethernet 01 switch port. All right, trunking mode, native VLAN, access mode VLAN, VLAN 1. Look for the lines operational mode, static access, access mode VLAN 1. We just did that. Operational mode, operational trunking, operational mode, static access, okay. Move to configuration mode and change the access VLAN for port Empire host 01 to VLAN 10 with the following commands. All right. So let's get out of here. Conf T interface Ethernet 01 switch port mode access switch port access VLAN 10. Exit. Switch port mode access. The default mode is a dynamic auto, as could be seen from the output show interface switch port above. This mode works for hosts, but results in the switch attempting to negotiate a VLAN trunk with a connected device. For ports that are known to connect to single host, mode access is preferred. Switch port access VLAN 10. This changes the VLAN that the interface will use when operating in mode static access. Repeat the configuration for the other 3 hosts. Pay special attention to VLAN ID. All right, so we need to do interface 01 we've just done. Interface Ethernet 02. Switch port mode access. Switch port access VLAN 20. Exit. And now interface Ethernet 1/0. Interface range. I want to do them both at the same time. 1/0, comma, 0/3. Ethernet 0/3. All right, so we're going to configure both of these at the same time. Switch port mode access. Switch port access VLAN 30. All right, good. Repeat the configuration for the other 3 hosts. Pay special attention to the VLAN ID. Exit configuration mode. Verify the updated VLAN configuration. Show VLAN brief compared to the table above. Use that. Okay, blah, blah, blah. All right, so let's do show VLAN brief. And now 01 is in VLAN 10. 02 is in VLAN 20. And 03 and 10 are in 30. Great. Now that we've segmented our network into 3 VLANs, let's see the impact to connectivity. So open the console for IoT host 1, attempt to ping 10.0.1, 10.0.4, okay. So IoT host 1. We're going to try to ping, first of all, 10.0.4 in our same VLAN, and that should be successful. And it is. Excellent. And so that traffic can see each other. That traffic can see other traffic from the same host in the same VLAN. All right, now we're going to go from VLAN 30 and try to ping VLAN 20 by pinging guest host 01, 10.0.2, and this should not be successful. And it is not. 100% packet loss. 10.0.1, same thing, should not be successful. And it is not. 100% packet loss. All right, so that's good. The first 2 pings fail because IoT host, employee host, and guest host are all in different VLANs. And the last ping works because the 2 IoT hosts are in the same VLAN. All right. Conclusion. We have now been able to take a single switch and use VLANs to create 3 virtual switches, i.e. virtual LANs. All right. Demo 3, multi-switch networks and VLAN trunks. Okay, this is kind of cool. So let's back this out a little bit. So that was interesting. So how do we segment traffic on our network so that only devices that we want to be able to communicate with one another can and other devices cannot? We can do that with VLANs, just like we did with a single switch. All right, demo 3. Let's make this a little bit bigger. Multi-switch networks and VLAN trunks. So we've got 2 switches, 3 VLANs, and let's get started. Now that we have created VLANs, we are going to look at how we can handle capacity in a network by adding additional switches to our VLAN segmented network. Reasons for an additional switch may be needed. Reasons an additional switch may be needed include when the existing switch at a location runs out of available ports, when adding a new location, such as a new floor or a building. In the starting network, there are 2 switches, each with a host in each of the VLANs. The hosts have been segmented into VLANs 10, 20, and 30 already. The switches have been linked together on ports Ethernet 1.1, 1.2, and 1.3, each one of each for each of the network segments. In this demonstration, we will first configure these inter-switch links as access ports, just like we did in demo 2 for the host systems. Then we'll explore the better option for connecting switches together, VLAN trunks. To create network segments that span multiple switches by using VLAN trunks, that's the goal. Okay, so testing the current state. Before we begin connecting the VLANs across switches together, let's verify that hosts on different switches can not communicate. Open employee host 11 that is connected to switch 01, employee host 11 that is connected to switch 01. Don't need this in this anymore. Cisco. All right, attempt to ping employee host 12 with the command ping 192.168.1.12. This should be unsuccessful. So employee host 12. So essentially there's no connectivity between these 2. Ping 192.168.2.12 should be unsuccessful. And it is. Repeat this test with guest host 11 and IoT host 12 by trying to ping the respective host 02 on switch 02. These should be unsuccessful. Okay, we will just assume that's the case. Configuring inter-switch links as access ports. Similar to how in demo 1 we started by adding a new dedicated switch for each segment and then exploring using VLANs and a single switch, we will first see how we can use dedicated interfaces for each segment. All right, so purpose, employees, guests, IoT devices, Ethernet 1, 2, and 3, VLAN 10, 20, and 30. All right, so the same interface is used for both switches. Okay, so open the console on switch 01. Check the current VLAN configuration for interfaces 1 through 3 with the show VLAN brief. All the 3 interfaces should be listed as ports for VLAN 1. Okay, so let's do that real quick. Jump on the console for switch 01. En, show VLAN brief. And check the current VLAN configuration for internet, show VLAN brief. Okay. All 3 interfaces should be listed as ports for VLAN 1. Oh, you're right. Okay, so 1.1, 1.2, and 1.3, as we see here, are all on VLAN 1. Okay, so we have to match those up to the correct VLANs that they belong to. Move into configuration mode and configure the access VLANs for each interface as shown in the table. Use the same commands from demo 2. Exit configuration mode. Okay, so we're going to do the same thing basically. So conf t, let's do 1.1 first. Interface Ethernet 1.1. I was just thinking, can we do them all? But no, we can't. Okay, interface Ethernet 1.1, switch port mode access, switch port access VLAN, and 1.1 is going to be 10. Exit. Interface Ethernet 1.2, switch port mode access, switch port access VLAN 20. We're getting some mismatches because the analogous interface on the other side on switch 2 does not match, and we'll resolve that in a moment. Exit. All right, and then interface Ethernet 1.3, switch port mode access, switch port access VLAN 30. Exit. Now we want to go over to switch 2 and do the same thing so that they line up. enconf t, interface, let's just do 1.1, Ethernet 1.1, switch port mode access, switch port access VLAN 10, interface Ethernet 1.2, switch port mode access, switch port access VLAN 20, exit, interface Ethernet 1.3, switch port mode access, switch port access VLAN 30, exit. All right, getting some reps in, that's good. Okay, so blah, 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 check the current, okay, so testing, concurrent, open switch 2, repeat the configuration and verification, good. Do show VLAN brief, and now the appropriate interfaces are in their correct VLANs, it looks like. Yes, I think I didn't make any mistakes. Let me jump on to switch 1 and just do the same thing. Do show VLAN brief, and it looks like they're all lined up correctly. Okay, with the inter-switch links configured, we can now test that communications are successful. Open the console for employee host 11 that is connected to switch 01. Attempt to ping employee host 12, 192.168. So employee host 11 wants to now ping across to switch 2 and get to the other host in its own VLAN, so across the switch, so across a different switch. Ping 192.168.1.12. And that is successful. So because we've configured these ports to be in the correct VLANs, now guests, or I should say hosts, on one VLAN connected to a switch can ping hosts on the same VLAN connected to a different switch. But we should also test that we can't ping different hosts on the other switch. So let's try that. So I'm going to try to ping guest host from employee host in a separate VLAN, 2.12, and that should fail, which it does. All right. So testing inter-switch connectivity, inter-switch, blah, blah, blah. We did that. All right, so now improving inter-switch links with a single VLAN trunk. Just like it doesn't scale to add a new unmanaged switch for each new network segment, it doesn't make sense to need separate interfaces for each VLAN when connecting two switches together. Instead, network engineers use VLAN trunks, single interfaces that can service multiple VLANs while maintaining network isolation and segmentation. Pretty cool. VLAN trunks are created with the 802.1q standard trunking protocol. This protocol adds a VLAN tag to each frame sent on the trunk interface. The tag includes the VLAN ID number. The receiving device can then read this tag to determine what VLAN or segment the traffic belongs in. Let's reconfigure our network to use a single 802.1q VLAN trunk interface instead of 3 separate links. Okay, so these 3 links here are the ones we're talking about that we want to consolidate into one link and yet still have all 3 VLANs communicate over that single link. Okay, first we will shut down interfaces, Ethernet 1.2 and Ethernet 1.3 on both switches. Okay, so switch 1, interface, Ethernet, what did we say? 1.2, shut, exit, and then Ethernet 1.3. Shut, exit. All right, we can already see the syslog messages saying that they are being administratively set down. Okay. 1.2 and 1.3, good. On both switches. Interface Ethernet 1.2, shut, exit. Interface Ethernet 1.3, shut, exit. Repeat, blah, blah, blah. Okay, so now test connectivity for the hosts on the segments using ping commands. Employee host 11 should be able to successfully ping employee host 12 because we left Ethernet 1.1 enabled. However, the other ones should not be able to ping because their interfaces are down. That makes sense. Okay, fine. I don't really feel like I need to test this, but can employee host 11 still ping? What was employee host? I don't think it should actually. No, the only one that should still be able to ping, what did I do? 1.2 and 1.3 are down. Switch 02. 1.2 and 1.3 are down. So employee host 11 should, I had a typo. 1.12 should still be able to ping 1.12, which it can. Okay. So we did that. Test connectivity, this stuff. Okay, we just did that. Change the configuration on Ethernet 1.1 from static access to static trunk. On each switch, open the console and go into Ethernet 1.1. All right, so interface, Ethernet 1.1. Now we're going to say switch port encapsulation, switch port trunk encapsulation .1q, switch port mode trunk exit. And now this one, interface Ethernet 1.1, switch port trunk encapsulation .1q, switch port mode trunk. Good. Note, .1q is an industry standard trunking protocol. ISL is a Cisco trunking protocol that has been deprecated in favor of the standard .1q. Exit, okay. Verify the interface is now trunking. On each switch, check the trunking configuration, show interface Ethernet 1.1 trunk. Notice the encapsulation in the trunking state. Notice the VLANs and spanning tree not pruned. Check the switch port status, blah, blah, blah. Notice the values for administrative mode. All right, so do switch port, no. No. Oh, I see. Show interface Ethernet 1.1. Switch port. There we go. So what do we got now? Administrative mode, operational mode, trunk, it's enabled, encapsulations .1Q. All right, so we've basically everything we just configured. Test inter-switch connectivity with the Vlan trunk. With the trunk configured, once more, test the ability for each host to communicate with its peer. Employee 11 should be able to ping employee 12. Can all VLANs communicate across this trunk link already? Anyway, let's try it. So employee 11, can it still communicate with employee host 12? Yes, it can. All right, now guest host 11, Cisco, can it ping guest host 12? Ping 192.168.2.12. Yes, it can. I guess I'm just a little surprised that we didn't have to do another step to add all VLANs to this Ethernet 1.1 interface. I would have, by default, expected it only to still carry VLAN 10 without an additional step. But I guess once you make it a trunk link, all configured VLANs on each switch will immediately flow across, and they'll just have the tag. So it makes it even easier, I guess. All right, so we did all that. We tested the inter-switch connectivity, blah, blah, blah. Now that we've configured a VLAN trunk between the switches, hosts connected to new future VLANs we create on our switches will be able to communicate without needing to add new links between both switches. All right, moving along to demo 4, inter-VLAN routing. It looks like this is the last demo. Okay. Inter-VLAN routing. Our last step in implementing VLANs in our network is to set up routing so that hosts on one VLAN can communicate with hosts on other VLANs. There are two approaches to inter-VLAN routing that we might want to explore. Router on a stick. This option leverages a dedicated router connected to the switches with a VLAN trunk. The router has sub-interfaces in each VLAN and can forward traffic between the networks. This option is best for networks with switches that are layer 2 only and can't handle routing. And then switched virtual interfaces, SVIs. This option requires layer 3 switches, sometimes known as multi-layer switches. These switches have the ability to act as a router in addition to being a switch. You'll create VLAN interfaces for each VLAN that will forward traffic between the networks. Only one of the two options should be configured and enabled on a network at one time. The goal is configure routing between networks using both router on a stick and SVIs. All right, so let's get back to our lab here. So we got demo 3 there, demo 4 inter-VLAN routing. We just got that one little box there. All right, locate router 01 in the demo 4 box, which we just did. Add a link from router 01 interface Ethernet 00 to switch 02 interface Ethernet 00. Add a link to switch 02, 00 to 00. Okay. Now we'll configure the switch interface to be an 802.1 trunk, just like we did between the switches. All right. So let's go to switch 02, conf t, interface, not it interface, interface Ethernet 00. Switch port trunk encapsulation .1Q, switch port mode trunk. I think that's it. And we want to do no shut, although I don't know if we have to. Exit. Okay. Now we'll configure the router on the stick. Open the console for router 01. And get rid of some of these from previous switch 02 we can keep. Open the console for router 01, EN, okay. Enable the physical interface connected to the switch. That's Ethernet 00. So interface conf T, interface Ethernet 00, no shut. Okay. No IP address or other configuration is applied to the physical interface. We will be creating sub-interfaces for each VLAN, but the physical interface is shut down. Oh, but if the physical interface is shut down, none of these sub-interfaces will work. I got it. Create sub-interface Ethernet 00.10 for VLAN 10 with the following commands. All right, so back here, interface Ethernet 00.10. So now we're in sub-interface configuration mode. Encapsulation.1q. Oh, encapsulation.1q VLAN number, VLAN ID 10, and then we give it an IP address 192.168.1.1, and that should map to the subnet that our thing is on, 192.168.1.1/24 for VLAN 10. IP address 192.168.1.1. That makes sense. 1.1/24. Exit. Okay. Subinterfaces are created by adding .number to the interface name. The number used typically matches the VLAN the subinterface will be placed on, but it is not mandatory to match. The command encapsulation.1q associates this subinterface with VLAN 10. All right, so repeat the process. So now we have to do interface Ethernet 00, so the same interface, but a different subinterface, .20. Encapsulation.1q20. IP address 192.168.2.1 for the 192.168.2.1/2.0/24 network. Exit. And for number 3, okay, so interface Ethernet 00.30. Encapsulation.1q30. IP address 192.168.3.1.255.255.255.0. Exit. Subinterfaces, repeat the process. You can verify the interface configuration on the router with the command show IP interface brief. Okay, fine. Do show IP interface brief. And we've got the 3 subinterfaces, .1, .2, .3 in the 3rd octet. All up, looking good. So we're going to test router on the stick. Open employee host 11. Console. Try to ping guest host 12, 192.168.2.12. It should be successful. Okay, so we're going to try to ping inter VLAN. So can I ping one VLAN to another if so desired over using a router on a stick? And just so it's clear, it's called router on a stick because you have this whole infrastructure and then the requests are going to have to go up to the router on this stick and then come back down into the correct place they're supposed to go. 168.2, what did it say? 2.12. I'm trying to ping guest host 2.12. So can employee host ping blue guest host over here? And yes, it can. So that's successful. Try to ping IoT host 12. All right. IoT host 12 over there. 3. And successful. So we are routing between the VLANs. If the pings are not working, try this stuff. They are working. But just to say what these steps you might use to debug this, wait 60 seconds and try again, wait for spanning tree to converge. Did you connect router 01 to switch 02? Did you connect the interfaces 00 on both devices? Did you configure switch 02 Ethernet 00 as a trunk? Did you use the correct VLAN number on the encapsulation .1q commands? Did you use the correct IP addresses for the VLAN subinterfaces? So a good little set of questions to ask yourself if things are not working and you need to debug. So great job. You've configured inter-VLAN routing with router on a stick. Disabling router on a stick. Before we can configure switch virtual interface routing on the switches, we need to disconnect our router on a stick. This can be done by simply removing the router configuration, shutting down the interfaces, or deleting the link. We will do this by removing the link connecting the router to the switch. So we can just basically come up here, select this link, and delete it. Okay, delete the link, verify that you can no longer ping guest host from employee host 01. All right, so let's try that again. And now that the link is missing, we can't route to the other VLANs. Okay, so configuring switched virtual interfaces SVI routing. So open the switch 01 console, switch 01. This must be a layer 3 switch. Good. Enter configuration mode and enable the layer 3 features of the switch with the following command. So en conf t configuration mode IP routing. So we're going to say, okay, you're now going to be routing layer 3 packets. Some switches might have this command enabled by default, but doesn't hurt to get into the habit of configuring it. Okay. Create interface VLAN 10 for the employee's network with the following commands. Okay. Interface VLAN 10, no shut, IP address 192.168.1.1, and it says /24. So again, mapping to what we did previously with the router. Exit. Repeat the steps. So we've got interface VLAN 20, no shut, IP address 192.168. Always making that mistake. 2.1, 255.255.255.0. Exit. And then interface VLAN 30. IP address, we gotta say no shut. IP address 192.168.3.1 /24. Exit. All right, so let's do show IP interface brief. I messed that up. Interface brief. We've got VLAN 10, 20, and 30, .1, .2, .3, all up. That's looking good. You can verify it, which we just did. All right, so now let's test these. So opening console employee host 11. And can we ping guest host 12? So can employee host 11 ping guest host 12 using the inter-VLAN routing offered by this layer 3 switch as opposed to the router on the stick. All right, so first of all, can we ping in our own VLAN 1.12 from 1.11? Yes. And then can we ping in a different VLAN from our own? Yes, we can. All right. Try to ping guest host 12, IoT host 12, and for the heck of it, why not 3? IoT host 12, 3.12. All of them are reachable. If the pings did not work, check the following. Did you use the correct VLAN numbers when creating interface VLAN? Did you use the correct IP address? Okay, great job. You configured inter-VLAN routing with switched virtual interfaces. All right, and that's the end of the lab. So a lot of information, a lot of good content. I mean, great learning, great preparation for the CCNA and just learning about how VLANs work in general. So I'm really glad I found this resource. I will definitely continue to walk through these guided labs with you all and get more familiar with CML and some of this content. So hope you all have a good rest of your day. I enjoyed studying with you over lunch. Talk to you soon. Have a good one. Bye.